Hello and welcome. My name is Oliver Lim, and today I'll be your presenter for the webinar. Today's topic is advanced part handling. I've sectioned out this webinar into topics. So first, I'll be going over what a part handler is, why a company would want to use one, some examples of machines that we can run, tech used by SigmaNEST behind the scenes, reports, and live demonstrations of significant features and machine types. So what is a part handler? It's essentially a load or unload system that attaches to a machine and unloads parts by picking them up via suction cups or even magnets for much heavier parts. They can be activated based on the programmer's choosing, then stacked onto a table of their choice. Some of the machines are even capable of using this part handler to load sheets and also remove the skeleton when done. It's important to understand that almost every part handler is unique, and depending on the machine's brand, the capabilities and constraints vary greatly. For example, I'm able to freely move the part handler around in any direction on this Murata, in this image here. But the Trump's movement would be much more restricted just to left and right. So I'll be showing the differences during the demonstration towards the end. So why would I need a part handler? These machines are designed to perform repetitive tasks fairly quickly, so this frees up some time for the operator to maybe run multiple machines and take care of other important tasks. Some of our other customers even run machines lights out, which could really boost production and output save and lots of time. Another big advantage of some part handlers is removing the need for tabs, since they have a lot of subhead movement that would release the part before it gets up. This prevents the need to break the parts loose from the sheet, then deburr them. So there's lots of time saved in secondary processes. And lastly, at the end of the day, you're getting more parts in less time, so that's always a good thing. So I want to show you a series of machines we can run and show you the visual differences represented in SigmaNEST. First up is the Murata, and as you can see, it's got a left-hand rectangular area that extends out, and also on the right. Beneath this panel is a bunch of suction cups that can activate as you put them over a part. This is a Whitney 3400 with a part handler arm, and it swivels on the left side while keeping the pickup area parallel to the sheet boundaries. So as you can see over here, SigmaNEST represents this accurately as it swivels along this point. This is a Trump TruePunch 5000, and it's a bit different from the others because the part handler can only move left and right because of this rail over here. The last one is an Amada EMZ with a TK handler, and it's got two arms that can separate, and the top one can move independently of the others, as you can see here in this SigmaNEST image. With so many unique settings per machine, there had to be a way to model each machine effectively, and we use XML templates to accomplish this. This technology gives us the flexibility to use multiple machines even though they're radically different. This also gives us room to customize and develop for machines that could be released in the future. Alright, so I'm going to switch gears here, and I'm going to show you some important features within Part Handler that makes the workflow very convenient for our programmers. Alright, so I'm inside SigmaNEST now, and I've got a bunch of parts already loaded. In this nest, I already have a bunch of parts already nested as well and seed. So for those of you who are not familiar with part removal, its function is to allow SigmaNEST to add these hits at the bottom. If you can see these logos, these are small hits on the bottom left corner of each part. And this is essentially a subhead hit. And right before the part handler picks up the machine, it'll do that hit, releasing the part from the plate. Now earlier I was talking about tabbing and how this isn't necessary for these machines usually. And this is exactly that reason. It doesn't need to tab it until it does this part here, and then it releases it from the plate. So as you can see in these categories here, SigmaNEST can determine the size of a part based on these constraints that you have here. So right now I've got small, medium, large, and I've also got this drop door here. So for guys with machines that have a drop door into a bin, SigmaNEST is capable of doing that all within this window. I'm going to go ahead and concentrate on this button here. So if I click on this handler button, it opens this interface up. Notice how it has a picture of the machine handler, and I'm able to even move this out because this machine is capable of doing that. This machine also has a swiveling suction cup towards the bottom there. The whole point of this is just to cover more ground when you want a part that's a lot longer and you need some more reach. So I can move this along like this, and notice how these cups turn red and activate as they're over a part. This is kind of cool because SigmaNEST calculates each part weight based on the material and the thickness, and also the density that you put inside SigmaNEST. So as you hover over a part, it'll turn red and tell you if you can pick it up or not. So right now, as I'm hovered over this part, notice how all these activate. I want you to focus on this blue dot here. This is the center of gravity of the part. So as a programmer, I want to strategically place these cups over this just to evenly pick this part up. I don't want to be towards the right too much here because now this part would drag. So once I'm ready to pick this up, I can hit pick up. And the order in which I click, it pops up on the right here in that pickup list. So let's go to the bottom one here, pick that one up. And I want to try use a feature here that makes our lives a little bit easier. Instead of me clicking 3 times for this, I could right click and hit same rotation. Notice how it just picked up all 3 of those parts with 1 click. This is really convenient. So these guys are actually different rotations, so I'm going to pick them up manually. Alright, so once I'm done picking all these parts up, I'll go to this part drop section. Now this is somewhat similar to the previous section, except now I'm just dropping them onto this palette area. So this is a configuration that I've already set up, and these demarcation lines in blue are basically where the pallets are separated. So I know this part's really long, so it's going to intersect, and that's okay. I'm just going to place this right here with a right click. Place this there. Basically just going to keep clicking around until all these parts are placed. And notice how this list is populating as I'm clicking. Okay, great. So now I'm done dropping all these parts. Now what I want to do is back up a little bit and try a different method of dropping these. So I'm going to cancel all these drops that I just did. And I want to try use this setting here called Mimic Nest. Now, if I go back to my nest here and I just observe how this looks like, notice how this nest is. And say as a programmer, I don't want to keep clicking around manually. I just want this drop area to mimic what I nested there. So if I click this button, notice how it just places everything all within 1 click. This is really convenient and saves a lot of time. So I'll go ahead and hit OK, indicating that I'm done. And that's pretty much that for this machine. All right, so I'm going to go to the next slide here, reports. SigmaNEST has a set of reports that you can use to mimic what I have here. Out of the box, we have something called a task drop layout report, and notice how it's got an image of the table in the background. This is really nice because as a programmer, I could just see where my parts are stacked. And also, notice on the left here, I have a tool use report. So the whole point of this report is just to see in the turret, where my tools are located, and I've combined both, so it's nice to have both of these. All right, so I'm going to switch gears here, and I'm going to move over to the Whitney. So I'm going to go back into SigmaNEST, choose my Whitney configuration, and I just want to show you the difference between this and the Murata. So I'm going to open the Whitney. All right, so I have all these parts here already ready to go. And let's just take a look at this nest here. So I've got these parts on this first one, and I have this and this. So I've got 3 sheets here. And I'll enter through part removal, same exact way how we did previously. Now, for this one, I can actually click this category and say these are the parts that I want part handled. So I can click on this and go to the next sheet, categorize those parts. Same with this. And now I'll go back into the part handler and look how different this machine is. You see how this one swivels on this point over here while maintaining this horizontally and parallel to this. In concept though, it's pretty much exactly the same in how this all works. So you're still going to have your part weight, the estimated force in which to pick it up, etc. So I'm going to right click on this, pick this one up. Same with this one, pick that up. Now I'm going to go to my drop area, drop my first part, and I can actually select this second cart, right click, and now I dropped it on that. So now I've got my parts placed on both pellets. All right, so I'm pretty much done with that. Now I'm going to try to replicate a real world scenario. Now say I wanted to keep those 2 pallets in the same exact place and I didn't want to move it, but I also want to take care of this second sheet here. So while keeping those 2 pallets there, I can go back into this part handler and take care of these parts. And I can go back to this part drop area. All right, now I dropped all those parts. And notice how these 2 parts are kind of just overlapping like this. This is the previous one that I had, and I'm just stacking them right on top of that. Okay, so I'm pretty much done with this section for this machine. I just wanted to show you those differences and see how the visual representation when you go inside part handler would be different. All right, so I'm going to go ahead and switch to my last machine here. It's going to be the Trump. Okay, so I got some parts loaded for the trunk. Let's take a look at this. Okay, so this is the first nest. Going to be going to part removal, same exact way we're doing. This one is just called the sheet master. I'm going to go ahead and click on handler to open that same exact window. And I want you to notice the difference here. Notice how with the other machines, I can move them up and down, but this one I can only move left and right. So this is specific to this trunk because it's on a rail. However, everything else is pretty much the same, just picking things up. All right, so now I'm ready to drop it. So it looks a little bit, yeah, that's fine. I'm just gonna leave it right there. All right, so now I can hit OK here. Let's take a look at this next one. Looks like the only part that was a part handler part was that bottom one. See the upper one? It's kind of grayed out. That's all through the part removal window. So this one, I'm just going to right click this, pick that up. I'm just going to stack it right over here. this one's pretty much done too. All right, I'm going to turn this over to Kevin. He's going to show you guys the Amada TK handler, and this one's going to be in metric.
Here we have an example using an Amada turret punch with the TK part removal system. In this particular case, it's an EMZ punch, but the equipment can be fitted on any of the modern Amada electromechanical punches. So here we have a nest of parts already nested and tooled. We'll quickly check to make sure our positions are good, and in this case we have two positions, some parts coming out in the first, some parts coming out in the second. That looks fine. So now we're going to go to the part removal section of the software. There are three categories. There's the micro-jointed parts, of which there are not any in this example. We have parts which are coming out with the TK, and we have parts which are, hypothetically removed manually. I don't have any in this case, although for a user it is quite easy to just say, okay, I want to remove this part manually. If we do that, the final hit is moved to a position where it's more convenient for the operator to get to that part. Although it's pretty impractical on a punch to do that, it's either going to be micro-jointed in or will be removed robotically. So I will just change that part back to the robotic removal. And now the separation hit or drop hit is placed in the correct orientation. The hit is automatically placed where it needs to be because the turret is really up in this top left corner. So by having the hit in that area, it exposes the part to make it available for pickup. So now we'll go into the TK screen. So here we get the view of the nest, and the parts are highlighted and served up to the user in the order that they will be completed. So here I have the TK unit itself. The TK unit is a twin arm unit. It's got a primary arm and a secondary arm which follows it. So this is the primary arm on the bottom, and then this is the secondary arm. The secondary arm can move independently of the primary, but when we move the primary, the secondary comes along. And this is modeled according to the behavior of the real machine in the physical world. So when I want to pick up my part, all I do is I position the primary where I want it. Now, I can position the secondary separately, for instance like this, stagger it, although in practice there's usually not much need. So we'll leave it like that and we'll say pick up. We'll go to my next part and I'll say pick up. I can do it with the right click menu as well. And then down in this one, I'm going to move this arm out of the way. Now, when I move it partially out of the way, SigmaNEST already knows in the real world we want to park the arm. So out on the real machine, this arm B will actually stay in the park position and won't come forward at all. We will just execute the removal operation using the one arm. And we'll say pick up. Now, of course, all of the other features that you've already seen, are available here. I can right click and I can turn on and off individual suction cups if I want to. Not always a reason to do that, but you can do it. And then of course, the user is probably also, switch it off. If you're a user, you're thinking about how you're picking up the part. For instance, I can pick it up here and the system says I have enough vacuum to pick the part up. But in practice, we all know that this left-hand end of the part will probably flop down and drag across the sheet. So that's not very desirable. So in each case, the user is making a good judgment here about where the best place to pick the part up is. And so on and so forth. Now in this case, I will use these arms and I'll spread them apart like this, so I get more coverage on a wide part. That's a typical example of when you would do that. Often if you have parts the full width of the sheet, that can really matter and can really make a big difference. Now let's say pick up, and then it automatically will attempt to match the position, so I can also work a little bit faster here if I'm a user. Now, all of the parts are picked up, and they're all in the pickup list here. So this is the pickup list. We have the drop list is empty, we haven't dropped anything yet. But we will go to the drop area, and we will begin dropping the parts. Now, the way this machine is organized in the production environment that we have it in currently is that the user is simply dropping the parts in the same orientation as they were in the nest. This makes for convenient part separation later. If there was an actual stacker connected or in a tower, maybe we would put stacks of parts back in the tower, but in this particular unit, we will simply mimic the nest, and then the drop coordinates are automatically synchronized up so that all of the parts are dropped like that. So in this case here, that's the operation. Pick up the parts and drop the parts on the Amada EMZ with the TK part removal system. Thank you very much.